Thanks for reminding me. Okay.
Yeah.
So the way we do that is we do a thing it's called ratios and proportions. Okay. Now, you guys don't know it, but you've already had experience with this or seen it at least. Okay. Right. And the easiest way to understand it is by recipes. Okay. Right. How many of you help your parents cook? Anybody?
I just cook.
So sometimes some of you just cook, some of you help your
I
parents.
cook by myself all the time.
Okay.
I make myself breakfast, lunch, and dinner some days.
There you go.
Some days I don't.
Okay. Alrighty. So let me ask you this. Let's say I have a recipe for this is one of my favorites because I'm from New Mexico. Green chili stew.
Excuse me, Mr. Honeycutt.
Yeah.
That says ratios and
Proportions.
proportions. Okay.
Proportions, yeah. Okay. So this is my favorite things on the planet, right? Because I didn't grow up here. I grew up in New Mexico where we eat lots of hot, spicy food. Okay. And so one of my favorite things is green chili stew. All right. All right. And it makes a big pot. I mean, it makes a big, big batch, right? Okay. So, but the recipe is just for me and my husband. Like there's nobody else in our house. Like I don't have kids, right? My dogs aren't going to eat this. I mean, they would eat it, but it'll probably make them really, really sick.
Wait, you're gay?
Yeah.
What?
You guys, I've talked about my husband before. Anyway, who cares? He's over there. He's somewhere else right now in the house. All right. Anyway, so what would I do, right, with this recipe? If it's so big, what would I do with it to make it fit just eating for two people to eat? What could I do with this recipe?
Cut it in half.
Oh, cut it in half. Exactly. So let's say I needed, the recipe was 3 pounds of chicken and 3 pounds of potatoes. All right. And let's say it's 1 onion and 4 cloves of garlic. Okay. And there's green chili and other stuff. So this is the actual recipe, just so you know, but I'm kind of making it up as I go. Okay. All right. So if I want to cut this in half, what do I have to do to each of these ingredients? What math thing?
Divided by 2.
Divided by 2. Or I can multiply it by a half. Isn't that going to be the same thing? Because remember, whole numbers are always over 1, right? So if I need 3 pounds of chicken, right, I would cut that in half, which would give me, what is half of 3?
1/2. 1 and 1/2.
1 and 1/2. And if I do this multiply, right, when we multiply fractions, we multiply straight across. So 3 times 1 is 3. 1 times 2 is 2. Well, 3 divided by 2 is, guess what? 1.5. Okay. So we would do that with each one of these ingredients, wouldn't we? So how many potatoes would I need? How many pounds of potatoes?
1 and 1/2.
Yep. How many onions?
Just 0.5.
Half of an onion, right? And how many cloves of garlic?
2.
2. All right. So now this is proportional. Okay. All right. So what we've done is we've taken our ratios of the ingredients, right? And we've made them smaller, each by the same amount. Okay. All righty. So this is how we can make it smaller. Okay. Let's say I'm going to have a big party, like my sister and my nephew are flying in, and then my dad comes up with his wife to visit, and it's me and Jeff, and I need to make this bigger to feed everybody. What could I do to make it bigger?
Add one of everything. Add one to everything.
I could, one of what?
Okay. 3 pounds of chicken. Add 1 more pound of chicken.
Okay, so I could increase everything by 1, but what's just a, could you think of it maybe a simpler way? What could I do with all my ingredients that's just easier, just to even think about, just easier? Well, in my brain, it's easier. It may not be.
Multiply it.
By what?
How many people are coming?
Yeah, I could do that. Or I could just, and if we cut everything in half to make it smaller, what could I do to make it bigger? That's pretty easy. Just double everything? What do you think about that? Would that make it bigger?
Yeah.
Yeah, it would. So a lot of times with recipes in real life, we cut things in half, or if we want more, we just simply double it. Okay, I don't know how much cooking you guys do, all right? But that's a typical practice. Like when when we could have parties and stuff, right? And I'd have people come over, like a lot of recipes I would just double because so many people would come over, okay? So in that case, we would take our ingredients, here's our 3 pounds of chicken, and we would, instead of multiplying by a half, we multiply by the whole number 2. And I'd want 6 pounds. That's a lot of chicken. 6 pounds of chicken is a lot of chicken. All right. But that's one way to do that. So this is what we do with proportions, right? To make things bigger or smaller. Okay. So let me show you how this works. I'm going to go back to my knitting example. Okay. All right. So let's say that I have a sweater, okay? And so you do it by sizes, okay? So like you do it by chest size. So they measure around your chest, okay? All right, so my chest measurement is about a 42 to 44, all right? I usually, depending on, the time of year and whether I'm in shape or not, right? So let's say I have a 44-inch chest, right? So that means I'm gonna want, right, to have a sweater, okay, that's actually 46 inches around, because you don't want it tight, right? Sweaters you wear over things, right? So you have a little bigger. So if I'm making a sweater for myself, okay, right, I'm going to start with 46 inches around, right? And what's going to happen is, like, I have to figure out, well, what is it going to be for other sizes? Well, let's say for my mom, right? My mom is tiny. Okay, let's say my mom has a 38-inch chest. Okay, so I need to figure, well, how much yarn do I need to make a sweater for my mom? Well, if I know that this sweater takes 2,000 yards of yarn, I need to figure out how much this is going to take. So that's what's in the magic fluffy cloud right there. Okay, so here's our comparison right here. Here, this is chest size, right? And this is yarn used. Okay, here's all around my mom's chest because she's tiny. Actually, she's probably tinier than that, right? So this is chest size here, but we don't know how much yarn to use here. Okay, but since we are proportional to each other, right? Meaning, like, if I stand next to you, we're all humans, right? We all have the same kind of heads. We all have arms and legs, right? We're just different sizes, right? So we're proportional to each other, okay? I can do this nifty cross multiply thing, and I can come and figure out how much yarn I'm gonna need. Okay, so if I do this math, you don't have to do this. I bet 46 times the fluffy cloud equals, well, where's my calculator? Hold on. Honeycutt doesn't want to burn his brain too much. All right, and go here, and let's see. What do I have here? 38.
Were we supposed to write all these like examples down?
No, you just watch, okay? All right, so 38 times 2,000 is 76,000. I know it looks weird, but I'm going to divide now. And divide it by 46. And I would need, the fluffy cloud, I would need 1,652 yards of yarn. Okay, so that's where see, these things happen in real life. Okay, we do the same things in real life. So when I designed this sweater, what I did was I made one like this for me. Okay, I have it somewhere. I need to fix it because my dog got a hold and chewed the buttons. I had different buttons on it than this. Okay, but I made one for me. And what I did for all the different sizes was I did this proportion problem to figure out how much I needed for all the other sizes. Okay, so we do this a lot in real life. And the one we do it the most with, I think, is cooking, because most people know how to cook and they make recipes bigger or they make things smaller, right? So all that's going all the time. All right, so this is a really, really important, probably one of the most important math life things you can learn is making things equally smaller or equally bigger. Okay, so that's what we're going to start into today. Questions on what I just showed you? I know it was a big math dump. Nope. All right, okay, so let's go to our Go formative now. Okay, so let me switch screens. All righty, and where's Go formative? Here it is. And that's not you. This is you. And we are in here now, I think. Oh, wait, no, it starts over here. Sorry, guys. Investigating ratios. This is when we were right here. 3.1.6 investigating ratios. Okay. All right, is everybody here? Are we all on? Okay, I'm not hearing a no, so I'm assuming yes. All right, so they give you this definition, kind of what I gave you, right? But it's more mathy. They're like, in mathematics, a ratio is used to express certain relationships between two or more quantities. All right, so like in my example, my quantities were the circumference around my body, my chest, compared to how much yarn I needed. Okay. All right. That's the comparison, the relationship. Okay. All right. So here you were working with ratios when you expressed portions as percents and fractions, which you were. You didn't. You probably, I don't know if you knew that. That's great. If you didn't, don't worry about it. Okay. All right. You also use ratios when you compare the portion of raisins or peanuts to the whole in the trail mix problem. Do you remember that, where we had the trail mix and we had to figure out the percentage of the trail mix that was peanuts and the percentage that was raisins? Do you remember that? That was a while ago. That was like 2 weeks ago. But we did that problem, right? That's the same idea. We're comparing things, okay? All right. I also use this example where I would compare, like, you know, when I was a kid, I loved Hot Wheels. I think they still have Hot Wheels, don't they? The little toy cars. Yeah. I mean, I love those. Those are like, I had a huge collection of Hot Wheels, right? I wish I still had them, but I don't, right? I had a huge collection of them. Well, I could say, well, let's do a comparison of toys, right? With my sisters. Okay. How many Hot Wheels do I have compared to Barbies? They're Barbies. Okay. So we could compare toys. Okay. So you can compare anything. All right. All right. So now we're going to do more comparisons. All right. All right. So let's go down here. Let's look at this one. Here we go. All right. I don't like this first example. We're going to skip this first example and we're going to go to this one. All right. So everybody skip number 1. Okay. Let's go down to this second example. Okay. All right. Rowena and Polly are investigating the trail mix problem. They need to get a life. All right. Rowena took a handful of her mixture and counted her raisins and peanuts. She found that she had 8 peanuts and 32 raisins. That's a big handful. God, I don't think my hand could hold 32 raisins. Anyway, all right. Maybe she used a cup measure. Maybe she scooped. I don't know. Anyway, she should have scooped because then she's just getting her gross germs in there. All right. Rowena drew the following diagram to represent her sample. Okay, so here are the peanuts on top because there are 8 of them. And here are all the raisins down here. There's 32. All right. It says here, you can use a ratio to compare the number of peanuts or raisins in this sample. Okay. All right. If you find what percent of the sample is made up of raisins or peanuts, you are writing a special kind of ratio. It describes how many raisins or peanuts would be present if the whole sample contained 100 raisins, okay, and 100 peanuts. If in fact, you can use the ratio to express the relationship between any 2 quantities, right? So that's kind of like the recipe problem. All right, here we go. Here's an example of a ratio, the problem above. A ratio of 40 to 32, comparing the total sample, 40 to the number of raisins and 40 to the number of raisins 32. Use this information to help you answer the following questions. All right, so here we go. All right, let me change my view. All right, so let us go back to here. Okay, so it says here, right? She has 8 peanuts to 32 raisins. All right, I'm just gonna hop back over to my iPad real quick, okay, because I want to write something down. Okay, now this is what I'd like you to write down too, okay? So what we're gonna do is we're gonna write down peanuts. We're gonna put a bar, and then we're gonna put raisins down here, R-A-I-S-I-N. Raisins is always spelled weird, I think. Raisins. All right. So when you first start doing ratios, it's really helpful to list top and bottom what you're comparing. See how I did that up here? I compared chest size to the yarn used. I'm doing the same thing, the peanuts compared to the raisins. Okay. All right. So my peanuts compared to raisins. We know that she got 8 peanuts in her handful and 32 raisins. Okay, so we write ratios like fractions. Okay, now some of you may have also seen ratios written this way with a colon in between like that. That's another way to write ratios, okay? I'm not wild about that way because if we need to talk about this as a problem, we have to turn it back into this. Okay, so you may see it like this, but I prefer it like this. So for my class, Mr. Honeycutt's class, we will always talk about ratios like fractions. Okay, even though they're comparisons, they still have properties of fractions. Okay, so I could say I could reduce this even further. What does 8 over 32 reduce to? What number can I divide into 8 and 32 evenly? What are some numbers? What are some numbers that go into 8 and 32 evenly?
2.
2 goes in there, right? So we could just, even if you can't see what the biggest one is, right? We can start with 2. Well, 2 goes into 8 4 times and 32 16 times. Can we make this smaller again? Is there another number that we can divide into 4 and 16? Can 2 go into it still?
Yes.
So let's do 2 again then. So 2 goes into 4 2 times and into 16 8 times. Can we go smaller again?
Yeah.
Yeah. What can now 2 again, right?
1/4.
1/4. Oh, so we could actually say that for every 1 peanut in that handful, she's going to get 4 raisins. Okay. Same idea. 8 peanuts to 32 raisins is the same as 1 peanut to 4 raisins. Okay, so while ratios are comparisons, they also take on little properties of fractions, just like this, okay, that we can reduce them and make them smaller. Okay, this is like, well, out of every handful you get, you're going to get 1 peanut in 4 raisins. Do you ever hear those commercials on TV or like on YouTube or something where they'll go like, 1 out of 4 dentists prefer this toothpaste?
Yes.
Yes, that's the same thing, right? So they take
Those
this
make me angry.
that and they say, hey, you know, 1 out of 4 people surveyed think that this is appropriate. Okay, it's a comparison, and it still takes on the properties of a fraction. Okay, all righty. So let me switch back to the screen, my computer screen. Okay, all righty. So here it says, match the following ratios of the sample of peanuts and raisins from the description below. Okay, all right. So it says here, a ratio of 8 to 32. Well, we know what that was. That was the ratio of peanuts to raisins, wasn't it? We know that one. That was this one. So we can just drag this and bring it over here. Okay. Oh, no, I put it in the wrong spot. You go here. Ratio of peanuts to raisins. Okay, I thought it stuck with it. Or does it go this way? There we go. All right. So sorry, I was putting it in the wrong spot. I need to drag it down here. So we know that 32 to 8 is the ratio of raisins to peanuts. All right. Now this, they tell us right here, this 40, right, is the total number of everything in the sample. Okay. Okay, so the sample, right, is a total of 40. Okay, so that handful, think about it, right? We have 32 raisins and 8 peanuts. That's the total sample because we added everything together. So be like, oh, well, how many pieces of stuff do you have in your handful of trail mix? Oh, I have 40 pieces of stuff. Let me see, count. Oh, yeah, I have 8 peanuts and the rest are raisins, so that's 32. Okay, so there's a total of 40 here altogether. All right, so not only can we compare the peanuts and the raisins together, we can take it to a whole nother level and we can compare like this one, the ratio of the raisins, 32, to the total. The total is 40. So this one, it comes down here because it is the ratio of raisins to the total. Okay. This one right here, I think, is already where it belongs. The ratio of peanuts to the total. See that right there? Peanuts to the total. And this one, 32 to 8, is they flipped it. Okay. And they've said, oh, now we're going to talk about the raisins to the peanuts. All right, so hold on 1 second. Isa, I see your hand up, sweetie, but let me just explain one more thing and then I'll take your question, okay? So give me a second. All right, so I'm going to switch back here. Okay, so in this instance, right, they talked about peanuts to raisins, okay? When you flip it the other way around, you're talking about raisins to peanuts. And to be honest, it's really not that much of a difference, okay? So instead of, and you just switch around, you go, oh, for every 4 raisins, you're gonna get 1 peanut. Or for every 32 raisins, you're gonna get 8 peanuts. It's pretty much the same. I don't really like put a big stake in whether you do it raisins to peanuts or peanuts to raisins, because it's kind of the same thing. Generally, this is just Mr. Honeycutt, I always tend to put the smaller comparison on top, That's just how I roll, but you'll see lots of different examples, okay? Asa, yes, sweetie.
Could you go back up to question 1? Because I don't think I quite got that on the Go formative.
We skipped question 1. We're not going to do question 1 because I don't like it.
I thought we did do it.
We didn't do it. Mr. Honeycutt did not like that question. When I read it yesterday, I went, ooh, I don't like that question. I can do that because I'm the teacher. All righty. Let's see
And
here. Now,
that's why
number
you're
3.
My favorite teacher.
What?
And that's why you're my favorite teacher.
Well, you may not say that now. Wait till you have me later on, and you'll be like, Mr. Honeycutt, you used to hate problems like that, and now you're making us do it. And I'll be like, that's because you're older now, and I'm meaner.
Yes, hopefully you like get up there with the mean teacher like you dreamed to be.
I really want to be a mean math teacher.
Yeah.
I've been trying for years to be a mean math teacher. I journal about it. I reflect on it.
You're too nice a person to be a mean math teacher, Honeycutt.
Don't see that. My goal is to be a mean math teacher.
I'm sorry I'm ruining your dreams, but you will be loved by all.
Mason, tell him he's a mad math teacher, okay?
Oh, well,
Come on, make his dreams come true.
we know I'm kind of crazy. That's okay. We can be that way.
The only way I could really make his dreams come true effectively is by cussing.
Mr. Honeycutt, give
So
us
I'm not
a
doing
surprise quiz.
All
Give
right.
us a
Here we go.
surprise quiz so we think you're a mad teacher.
Timothy, you're being worse than Honeycutt.
Here we go. All right. Let's regroup. Let's go ahead and regroup. Okay. All right. It says here, use what you learned about portions to describe what portion of Arena's sample is peanuts.
You're not screen sharing.
Oh, sorry. Thought I switched it back.
Hey Mason, do you mind muting, please? Thank you.
Thank you. Yeah, we all forget sometimes to do stuff like that. Like I forget to turn off my email and it goes bing, bing, and it gets really disturbing. So if I do that, remind me too. All right. So it says here, use what you know about this to describe it as a fraction and a percent. Well, I've already shown you how to do it as a fraction, right? So they want us to express what have you learned about portions to describe the portion of Rowena's sample is peanuts. Okay. So now this is worded weirdly. Okay. Just going to say. So they're asking us to say, what is the number of peanuts to the total in the sample? So when they say sample, that's what they mean. So how many peanuts did we have? Somebody tell me how many peanuts we had. Guys, how many peanuts were in the sample? Does this mean you guys are not paying attention? You're not on the right page?
What's your favorite color of the alphabet?
Guys, so this is what we're talking about. Somebody help me out here.
She had 8.
She had 8 peanuts, right? Okay. How many pieces are in the sample altogether? That's what they mean by sample. How many pieces altogether in the sample?
Isn't it 8?
No. Okay, so be careful, right? This is where you get to think, okay? So here's the sample. The sample is a handful, right? And in that handful, she had 8 peanuts and 32 raisins. So the sample is the whole thing together. That's our 100% is that handful. So how many things are in the handful altogether?
40.
40. So what we're doing is we're comparing the peanuts to the sample, okay? So we're going to hit 8 and then our slash to make it a fraction, and we're going to put in 40. Okay. So in this case, right, the 40 is the whole, right? Remember how I said ratios are kind of like fractions in a way, right? And denominator tells us what the whole is made up of, right? So here we can see that this handful, she has the whole amount, the 40% or the 100% is 40 altogether. And out of that 8 in that handful, she's got, or out of that handful of 40, God, I can't even talk anymore, is 8 peanuts, or are 8 peanuts. Okay. All right. So now if we want to describe this as a percent, right? What do we do to figure out percents? What's the process I would use to figure out this as a percent?
You would do 8% because you wouldn't put a whole number in it with percent.
Okay, well, hold on. Let's review real quick, okay? So remember, fractions, decimals, and percents are all the same thing. So here's what I'm dealing with right now, right? So what I want to do is I need to turn this into a decimal. Okay, so that's going to be my first step, to turn this into a decimal. How do I turn fractions into decimals? What's the process we did for that?
Oh, don't you move it to the side or something? Like you move it.
That's when we turn the decimal into a percent. But right now I need to turn this into a decimal. You got 4 choices: add, subtract, multiply, or divide.
Add, subtract, multiply, divide.
Guys, we did this. We did days of this. How do I turn a fraction into a decimal?
Don't you divide or?
Yes, I divide. What do I divide into what?
8 divide 40. Or 40 divided by 8.
The top is always divided by the bottom, right? Remember that? Remember? We did this. I'm going to have to do a review. Uh-oh. Worksheet time. Worksheet time. All right. So this is where, right? We look at this, we go, oh, how many sets of 40 are in 8? Well, there are no sets of 40 in 8. So I have to do my decimal point and make the number kind of bigger by faking it, right? So now we say, oh, well, how many sets of 40 are in 80? How many sets of 40 are in 80?
Sets of 40 are in 80. There are 2.
There are 2. So we know our answer, right, is 2/10. Okay. And how do we turn this into a percent? What do we do? Now, what do I do?
You move it over 2 places.
There we go. Move it over 2, and I'm going to fill in that spot. So what, oops, I'm thinking the peanuts again. I wrote down 8. What percent of the sample is peanuts?
20%.
20%. Okay, so do you guys see how this is all kind of going together?
Yes.
Right. So we did fractions, and then we turned fractions into decimals, and then we did decimals into percents. And now we're looking at ratios, the comparison, okay? And again, ratios, the comparisons kind of takes on little flavors of fractions, and this is one of them, okay? They're kind of like interchangeable. They kind of like each other, but they're hesitant sometimes. Sometimes they're like, I don't want to play with you today. You're bugging me, right? And other days they're like, I love you, you're my best friend, we're gonna play together. Those are ratios and fractions together. All right, so now we know that answer. Okay, so let's go, I'm gonna go back to my Go formative. I know that my fraction, right, is 8/40, but my percent is going to be, let me turn on the keyboard here. It's gonna be 20, oops. You know what, let me put a comma in there. I think that would be a good idea. No, it's not gonna let me put in a comma. Well, there's a comma. Oops, back up. Oh, Honeycut, do you see what I did? Oh. All right, try that again, Mr. Honeycut, jeez. All righty, comma. 20%. Where's my percent? There it is. So those are our two answers. So this is what we can talk about the numbers. Wow, in that handful, we had 8 peanuts to 40 pieces total. So the percent of the peanuts in the sample is 20%. Okay, this is what they do in the same thing when they do surveys, right? They would say, oh, 20% of these people think that Ben & Jerry's Cherry Garcia is the best flavor for Ben & Jerry's. I mean, that's what they do. They like survey people and they'll say like, okay, how many of you like, Cherry Garcia? And that's as your favorite thing, right? Same idea, right? We use these types of comparisons are used all the time. All right, questions on how I got these numbers? No? All right, let's go to the next one. Use what you've learned about portions to describe the portion of Rowena's sample. What of Rowena's sample is raisins, okay? All right, we're gonna do the same thing. Now in this one, we did peanuts to the total. Now we're gonna do raisins to the total. So how many raisins were there? Class, how many raisins were there?
There were 32, right?
32, right? Okay, so we're gonna type in 32.
I have a question.
Hold on a second, let's finish this real quick, okay? And then I'm gonna put in my slash to make a fraction. Okay, how many are in the total sample? How many pieces? Total, 40. Okay, what's your question, sweetie?
Okay, so for the percent, wouldn't it just be 80% because the other one's 20%?
Yes, I was gonna talk about that next. Who said that? Who made that amazing discovery? Oh my goodness, amazing. Yes, we don't really have to do any math for the percent because we know it's always gonna be 100%, right? And so if we're only talking about two things, all we have to do is subtract the 20% from 100% and we're left with 80%. We don't even have to do any super duper icky math. We know this is just going to be 80%. How awesome is that? Now, we don't always get to do, say if we're comparing like 4 things, well, then we're a little bit of a story, right? Then we're going to have to do each one individually until you get to the very last one. But if it's only 2 things, you got 100%, right? Well, if one's 20%, the other one's going to be 80%. So personally, I think that's way too many raisins to peanuts. I mean, I like raisins and I like peanuts, but I think really if I'm gonna have sweet and savory, I'm gonna want a pretty much even mix. I'm gonna want like 50-50 peanuts to raisins. That's my personal taste. Or maybe 60-40, I could go that route, okay? Alrighty. Okay, we are at 106. Tell you what, let's stop here for today and we will finish this next class. And then I'm going to get you guys a worksheet on fractions to decimals and percents so we can have a little more practice. Okay, let me make myself a note. Sorry, remember to get you that worksheet right now before I forget. Here's my pad o paper, my orange sticky notes because orange is the best color in the world.
Yeah, go orange. Woo.
Worksheet for 6th grade math, 6-7 math, sorry, not just 6th, 6th, 7th math. Yay! Okay, all right, guys, you go forth, have a wonderful day, and I will see you on Thursday.
Baba boy.
Boy.
Bye.
Mr. Honeycutt, can I do the victory wub wub?
No,
Pretty please?
I mean, no, I have to talk to a student, so you guys need to go away.
It's really quick,
No, you have to wait till next time.
No, I'm gonna do it because you're a great teacher, not a mean one.
Quiet.
Wub wub.
See See how mean I am? I just muted you.
Blah, 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 blah.
All right, guys.
Okay, well, first of all, I don't know, maybe you looked at the chat, but it would just be a lot easier if I could meet at 1:20 or 2:25. Is that okay?
2:20. I'm not going to be here today at 2:25, sweetie. I have a meeting with Mr. Page, the principal, that I'm going to go to next.
Okay.
So I have
and
to
then now
drive.
just
I have to go
remembered-
drive to see him. So it's not like I'm
Okay.
doing it on Zoom.
Okay. And now I just remembered that I said that wrong. I meant 1:25 because I have supervised study after this class, and we don't have a class for supervised study, so I'm done.
Oh, well, that's it. Yeah, sweetie, that's it. It's, I mean, I don't have class after, this is my plan time. So I teach 3 in a row, and then teachers all get a plan time, right? So my plan time is at the end of the day. So, we can always set that up and do it afterwards. So it's just, it doesn't have to, but you have to go check in with Mr. Roberts, don't you? Or
Yeah,
whoever.
yeah, that's the point. It'll take like a couple seconds, and then at 2:25, or 1:25, I can do it.
Or you know what I could do is I could just send an email to Mr. Roberts and just say that you're in my class.
Oh yeah, you can do that too if you want.
And then you can, when we get done, you can just go check in with him.
Okay, sure, that's fine.
Okay? We just need to remind me.
All right.
Okay, so do you want anything today? Because I need to, or do you want to talk about anything today?
Yeah, it was actually about the last worksheet we did.
Mm-hmm.
I have to find it again though. It's chart.
I can find it real quick.
Yeah, can you help me?
Because I have it right here.
It's not that.
Okay, let me share my screen. There it is.
Okay, so it is this one. Okay, cool. So I just needed help with 7 through 12. No, sorry, not 7. 5 through 12. For those.
Okay.
five.
So, all right. So Talia, I'm going to be real quick because I have that meeting, and I apologize because I promised you that I would go over this with you, but I'm going to have to
Okay.
do one quick, but then I'll make time for you. You can come on like Wednesday also during office hours.
Yeah, I'll do that.
We
Yeah,
can
yeah.
go over that too. Okay, so let's go over number 5 real quick. All right, let me change my screen and to my iPad so I can write. Okay, so the problem is 1/5 plus 1/3. Okay, right. So these are 2 different denominators. So the easiest way to do this is what I tell my kids, is to multiply across. So what is 5 times 3?
15.
All right. So then that's going to be your new denominator. So we're going to put that in each of these spots. Okay. All right. Now, what did I multiply this fraction by to get to 15? Hint. 5, right? Because we multiplied each of these by each other, right? So that means I'm going to multiply this numerator by 5. So what's 1 times 5?
5.
There you go. Okay. So now, what did I multiply this fraction by to get 15?
3.
3. So I'm going to multiply this numerator by 3. So what's 1 times 3?
3.
And now I can add them. 3 plus 5 is 8. And we don't worry about the denominators because they're the same. So what I tell my kids is I always draw this little diagram, right? Where let's look at what's the next one. Number 6 is 8/7 plus 4/3.
It says that I'm wrong for some reason on 5.
I could have typed something in wrong too, sweetie. Let me see. Number 5. What did I type in there? No, I have 8/15 in there. You know what, sweetie? If you put a space in or something, it gets really weird.
Okay, yeah, fixed it.
So
There we
if
go.
you do anything like that, it's going to tell you you're wrong. So if you put in like, a space or a comma or something like that, it's going to tell you you're wrong.
Okay.
Okay. So like the next one, right? I wrote that down. Let's go. You still see my iPad, don't you?
Yep.
Okay. All right. So same thing. I'm going to multiply these two together. And then, so those are the arrows I draw that way. And then I draw an arrow across to remind me how that multiply is going to go. So I'm going to do the side to side first. 7 times 3 is 21. Then I'm going to follow my arrows. 7 times 4, well, that's 28. And 3 times 8, well, that's 24. And now I can add these two together. 24 and 48 is 52. And that's your answer. And you don't need to turn these into improper fractions. Remember I told you that? We're only going to do improper fractions when we're talking about like baking or distance, okay? Is that better, this little diagram?
Yeah, that is better actually.
This is, and typically, and because I've done this for years, I know a lot of these by heart. But if I have a bigger fraction that I don't know, I think about this diagram in my head. This is how I think about it in my brain. Oh, I'm going to multiply those and then just multiply across. Okay. All right. I have to run and go beat Mr. Page. But if you want more help on this, then let's talk Wednesday. Okay.
Okay, perfect. That's great.
All right. Go get embarrassed by your mom some more. Bye, sweetie.
Never speak of it again.
I'm not. This is not going to happen. Bye, sweetie.
All right, thank you.
Bye.